Hello, and welcome to 5-Minute Math. Today we are looking at the third grade concept of comparing fractions, specifically how we can compare fractions with fraction strips, and we'll do it in 5 minutes or less. So we have some blank fraction strips here, and our question is, can we find some fractions that are greater than 3/8? Now, what we do here in third grade is we look at comparing fractions that either have the same numerator or the same denominator. So let's start with fractions that have the same denominator. So where are our eighths? Well, our eighths are going to be right here. So if I'm looking for 3/8, I'm just going to label these three right here. And these are going to be my 3/8. So if I have the same denominator, right, what I could do is I can look at any fractions that have more than just 3 parts out of that 8, right? So if I were to go this far out here, I could say that's 4/8 is going to be greater than 3/8 because you see we have the same denominator, and I've got 4 parts rather than 3 parts, and since we have the same denominator, we could just look at the numerators, and the 4 is larger than the 3. And obviously we can just extend this. We can say, all right, here's our 5/8. That's going to be greater than 3/8. And we could do the same thing with our 6/8, our 7/8, and our 8/8. As long as we have the same denominator, all we need to do is just look at the numerators, and we need to find a fraction that has a numerator larger than the one we are comparing with. That's the easy part. Let's see what happens when we try to compare fractions that have the same numerator and different denominators. So now we're looking for fractions that are greater than 3/8, and we want to keep the same numerator. Now, how can we do that? Well, this is the part that gets a little bit confusing. We actually need to find fractions with smaller denominators, right? So take a look at the row right above. I've got my eighths right here. Take a look at my row right above. These are sixths. So if I look at my sixths, take a look, and you can see that the 3/6 is going to be greater than the 3/8. Now, why is it? Because the 6 is smaller than 8. Well, it's because they each break apart a hole, and the hole is always represented by this big, long rectangle at the very top that has no lines cutting it up. And if you're going to take that same hole and cut it up into 6 pieces, and then compare it with the pieces that you use when you cut it up into 8 pieces, the smaller the pieces, the larger they're going to be. So since I'm breaking up this hole into 6 pieces, these sixths are actually going to be a little bit bigger than each of these eighths because I've got to cut this hole into 8 pieces rather than 6. Now we can look at this right up above. Fifths, I've got 1/5, 1/5, 1/5. And look at that, that 1/5 is definitely bigger than the 1/8. So my 3/5 are definitely going to be bigger than my 3/8 because I'm cutting that same hole only into 5 pieces this time rather than 8 pieces. And it gets really big when we look at the fourths. So look at my fourths here. Look how big. This 3/4 is almost the whole thing. Right, I'm only missing one piece. Look how far over that goes. 3/4 is definitely bigger than 3/8 because I'm taking that same hole and I'm cutting it only into 4 pieces rather than taking that same hole and cutting it into 8 pieces. Now, let me show you what happens if we look at a fraction that has a larger denominator. Okay, these are my 12ths. So let's look at these 12ths right here. I'm just going to look at these 3/12ths. Take a look. These 3/12ths are not very big. So 3/12ths are going to be less than 3/8 because I'm taking the same hole and I'm cutting it into 12 pieces rather than 8 pieces. So the larger the denominator, the smaller each piece is going to be.